Hello and good morning everyone, and thank you for joining our Barracuda Web Application Firewall webinar today. So we're joined here by Gemma Allen from Barracuda, who will be going through the webinar with you.
Hello there and good morning. So my name is Gemma Allen. I am a solutions architect at Barracuda, and I specialise in taking our devices and operating them in the public clouds. Today I'm going to talk in particular.
You need to hide your control panel.
Of course, yes. Forgot about that one.
Thank you.
So yes, today I'm going to talk about our solutions for Azure, and in particular the Web Application Firewall solution. So quick overview, I think, to get us started. So as many of you look at and investigate the cloud today, if you haven't already taken your first moves into it, some of the major concerns are the security of your applications once you put them up there. How do you control access into those solutions? How do you get your connectivity you need from your sites into those solutions? And what protection do you really have if it's publicly available to the world potentially? Now, many people presume, because the documentation of the cloud platform says they have things like DDoS protection and a number of security features, that means that their applications are automatically protected by all those features. And, well, yes they are, but no they're not. So you've got to think of the volume that Azure is now operating with. They are going to take care of the security of their solution. They're going to make sure it's available for you to run on. And they are going to take every endeavour to protect their network infrastructure to make sure that your user experience is not affected by malicious attacks. However, they are not going to do that at the more detailed level of your applications and your services in the cloud. So things like your network access security is not managed by Microsoft. It's up to you to configure and decide how you manage that. Microsoft, while they provide identity and access control solutions, again, they need your input on how to configure that and how to secure and tighten that so the right people have the right access. They also don't necessarily manage the security of your operating systems and the platforms that you're running in the cloud. They're providing you the hosting environment in which to run them, but you still need to concern yourselves with, who has file system permissions, what can get to that box and connect to it. And obviously data encryption services are provided by them, but that for the data at rest, the data in transit, and how do you want to manage that? So we offer solutions for the public clouds that will allow you to enhance your security there and implement security services as you would see on site. We have detailed logging on our products to help meet compliance regulations and auditing practices. Our solutions can enable hybrid scenarios, so you can move your systems to the cloud solutions quicker and easier with more reassurance about security. And because these are your devices, it is all under your control. You can do what you want with those devices. Now, we actually run 4 products in the public cloud: the Web Application Firewall, the Next Generation Firewall, the Email Security Gateway, and our Message Archiver. I'm going to go in today in the most detail of the WAF and the NG and how they interact, but our Email Security Gateway provides a spam firewall that operates in the cloud, and the Message Archiver uses the cloud storage to provide an archive of your email. It can also enhance Office 365 migrations and assist in, again, bumping up the level of Office 365 data retention. So the Web Application Firewall, which is the main objective of our webinar today. So the job of the Web Application Firewall, it's a dedicated device. Its main interest is inspecting your web traffic, HTTP and HTTPS traffic to be precise. So as that traffic comes into the WAF, it is going to be doing detailed inspection of that traffic. We're going to be looking in there for things like SQL injection attacks, cross-site scripting, any kind of cookie manipulation to make session data available. And we also are running some application DDoS, so we're looking to protect your site from a higher number of requests coming in than your servers behind are able to scale to. Nowadays, you've got new types of DDoS attacks, which would be a financial DDoS. Yes, the cloud can scale infinitely, but can your wallet scale infinitely alongside that? So at some point you may have to restrict how much traffic can actually get through to the back-end servers. We also have proactive controls there, so we can hide the applications behind. Nobody needs to know what your back-end servers are running. And we can control the IPs allowed access to your site either through geo-IP control or access control lists. And then we're looking at the outbound inspection. So as those servers respond through the WAF to the caller, we can inspect that data and look for custom patterns or known credit card numbers, and then we can proactively say we're not going to allow that data out, we're going to hide it, rewrite it, or deny the request entirely. Layered over all of that, the WAF is going to be logging all that information. It has 5 log files. I'll show you a little bit about those later. And all of those log files can be injected out into a third-party SIEM system such as Splunk or QRadar, or it can also integrate nowadays with the preview version of Azure Security Center. Lastly but not least, the WAF has a comprehensive set of authentication mechanisms it can apply on top to the traffic. So as those requests reach the WAF, you can decide whether or not a site is going to be secured by your Active Directory servers, by a SAML front end, by a Kerberos server, and you can mix and match those controls across your sites to provide a single sign-on experience for your users. So the way we normally see the WAF utilized in the cloud is to provide application security. So you've developed your application, you've migrated a legacy application, you want to know that the data coming into that application is not an attack. The Azure address spaces are public to the world, so anybody can get a list of them and start sniffing their way through Azure. So you want to stop that before it gets through to your application. We enable AD integration, so the access layer can tie into Azure AD and easily put that in front of your web applications without the development effort on your part. So again, legacy migrations into the cloud can start to support the newest technologies without having to put in the development effort in a dying application. Then ADFS, so we can use the WAFs to also provide the front-end proxy for ADFS. So you're going to get pre-authentication for that, you're going to get inspection of all the traffic coming into your ADFS servers, and you're going to utilize those boxes for an additional role. We can also enhance the load balancing provided by Azure. So our WAFs can add on to their cookie-based persistence, session-based persistence, again, legacy applications that need to move into the cloud but aren't cloud aware themselves can be enhanced by the WAF and enabled to function correctly. And then obviously the data loss prevention, so a lot of the use cases for the WAF would be to meet compliance around PCI DSS, and that's where the WAF's deep inspection of that HTTP traffic can help to make that viable. So the Web Application Firewall, as it sits in Azure, it is an IaaS virtual machine, so it runs in the infrastructure as a service components of Azure. You would put it in your virtual network alongside other virtual machines that you might run. The Azure Load Balancer provides the public IPs for the WAFs, and that passes the traffic to an active-active cluster of WAFs. So the minimum we would recommend you run is a pair. In this scenario, you can see we've scaled up to 4 or more devices. Because each of these WAFs is active, then every additional WAF you build into the cluster is increasing your resiliency and the throughput that the WAFs can handle. Now then, behind the WAFs will sit your servers. And those servers can be more IaaS virtual machines. They could be physical on-premise machines, providing you've got a connection between the WAF and on-premise. Or they could be new PaaS applications that you're developing. So we can integrate with app service environments, and we can interface with the old cloud service roles, and the WAF can again protect all that traffic as it comes into them, and you can also enable your migration path a lot smoother because it's always being presented by the WAF at the front end. Now, I'll briefly go on to the next generation firewall and how that can enhance and support the WAF. So the next generation firewall is a fully featured layer 7 firewall, so it is user aware. We commonly host these in Azure alongside the web application firewalls to provide the networking security that the WAFs just cannot. So say the WAFs are specialist devices, they primarily concern themselves with HTTP and HTTPS traffic. So the NG will go into the architecture to enable site-to-site and client-to-site VPN tunneling. It will enable you to develop a multi-tier architecture with the WAFs, the web servers and the database servers in different subnets to secure traffic between each of those networks. It can allow you to secure your express route traffic, either inspect it and log it, or tunnel securely through express route if you want the additional security of encryption. It gives you full view of your traffic going in and out of your environment. We can then enable some additional IPS and IDS functionality, as well as URL outbound control and antivirus control. So the WAF can stop people at the very edge, and the NG can back the WAF up with additional inspection. Now, what we have on this next slide is our recommended base infrastructure from which we start all security solution discussions. What you see here is a virtual network in Azure. Inside that virtual network we have implemented 5 subnets, one for the WAFs, one for the next generation firewalls, and 3 more for your web application and database tier. There can obviously be more or less in this design as needed. Now, the first thing we do is we allow in the traffic we want to allow in. So your users, your HTTP applications are going to come into the WAFs. Your site-to-site VPNs and client-to-site VPN links would come into the NG firewalls. Now, behind the scenes here, we're using an Azure feature. That feature is called user-defined routes, and that allows us to say for each of these subnets or tiers that you see on the screen here, that the gateway device to reach each other is going to be a different device from the natural VNet. So in this case, we're making the NGs the device through which everything can communicate. With that done now, we're starting to be able to block off direct communication. So the web tier can't directly talk to the WAF, and the app tier can't directly talk to the database tier. All that traffic is going through the NG firewalls. It's all being subjected to a regular firewall rule set that says port 80 from the WAFs to the web tier, port 1433 from the app tier to the database tier. So you've got full control and visibility of that traffic now. And that's where we add in the extra protection. So your user is going to come in through the WAF. The WAF is going to communicate with the web tier via the next generation firewall, which is going to provide any additional inspection if the WAF hasn't already blocked that traffic because it's an SSL injection attack or some other pattern that doesn't match our security policy on the WAF. Now, I say the other main scenario for the NG firewalls is to connect and secure the virtual networks. So providing VPN tunnels between on-premise solutions and the virtual networks in Azure. And with these in place, then you can start to use the WAF in a hybrid context. So the WAFs running in Azure can utilize these hybrid links, and providing the performance is acceptable, they can also provide a public front end for back-end applications and utilize those VPN links. Also, if you're starting to look at the bigger scenarios with express route tunnels, again, with the NG firewall there, then we can run a VPN up that express route link. That allows us to then start to do traffic shaping rules, but it also allows us to have failover to the internet. So the NG establishes a VPN tunnel that comprises of two transports, a transport up express route and a transport over the internet. We can then use our traffic intelligence and shaping policies to, one, prioritize traffic over that transport, and two, decide which transport what traffic needs to go down. So again, with that WAF doing the hybrid connectivity, or with the need to run a database tier on the back end, then you can say that I want my WAF traffic and my database traffic to be prioritized down the express route link. In the event of the express route link failing for any reason, I want it to be the #1 priority traffic down the internet link. And when the express route comes back, it will fail back to the express route link and be the priority traffic there again. Now lastly, the NG enhances the management of the solution. So all those site-to-site VPNs, you can get in and access and control your devices. With our CUDA launch application, you can do that from your mobile phone or tablet device. And with the SSL VPN, you can do that from your web browsers around the world. We also have centralized management control. In this case, for the NGs, we have a device called Control Center. Everything will securely connect back to that and take its configuration management from that. For the web application firewall, we have our online cloud control, where every web application firewall will talk back to our centralized management server. You have a login for that, you only associate your WAFs to that, and you can then import policies and apply templated policies across your WAFs. So every device can be kept the same. So on our Azure side, we have a comprehensive support process for people who want to try this out. www.barracuda.com/Azure is where you'll find the data sheets, technical briefs, case studies, and a number of videos on how each of these solutions can be implemented. But if you want a bit more of a custom experience and you want to just talk to somebody and understand how it could work, then obviously you can contact Bytes, but you can also just drop an email into Azure support at Barracuda, and we will work with you to understand your architecture and help you understand how our products might help. All of these products have a 30-day free trial running in Azure, so you can deploy them, try them out, work with us to see if they'll do what you need. And we can provide you a demo and a proof of concept and work with, again, Bytes to support you through that process. So what I'll just do now is we'll move out of the slideshow and I'll show you a little bit more about the web application firewall. Bear with me one moment as I just rearrange my screen sharing. Okay, so hopefully now you can all see a web browser in which we have the dashboard screen of the web application firewall. Now, I'm afraid I've cheated a little. This is one that I have made earlier. Or I'm borrowing a demo. The devices I run in Azure are a little boring for a demonstration. So what we see on the dashboard immediately is a high-level overview of the kind of traffic that is coming to the site. So already we're pointing out the key areas that the attacks are coming into. And this will change from day to day, even on our demo systems, which is getting live traffic. We can also see just to our right here the immediate status of the servers and the services that the WAF is supporting, as well as the system load and how its general storage is going for us. In this case, we can see we've got a high availability setup with 2 WAFs running. As I scroll down this page a little, you'll notice we've got our subscription status, and then more interestingly, we've got our attack information. So this is just showing me the last hour or so of attacks here, but I can adjust this screen as I need to see a bit more of an overview here. So we can see the attacks are categorized into what type of attack we're receiving. So injection attacks, SQL injections, script-based injections, session tampering, which is normally cookie attacks, but it could also be session IDs, and file attacks, whether or not we're receiving file uploads. You can also see here the kind of traffic throughput that's going through the device, and again, more detailed information of the performance and the number of requests coming into the WAF. So you can customize all of this as you need to for your sites and services. So as I said earlier, the WAF has 5 logs. In particular, the 3 of the most interest are the access logs, in which you will see all of the access requests being made into the web application firewall. And you will see quite good details about all of those requests. So if they're valid requests, what the status page is being received. You can see the user agents, whether it's a script or not. And you can see down to the detail of what does your server do about that page, which host gets it, does it respond, how long does it take. So you can start to take performance information out of here as well. Now the next most important log would normally be the web firewall logs. The web firewall logs show you the actions the WAF is and could take. So the web application firewall running in active mode will proactively deny and block anything that goes against its policies. So we can see here a number of attacks that were coming in. In this case, we can see we've got a SQL injection attack, which is going against the WAF itself and is being blocked. We can also see here we've got a header attack where somebody has been rather optimistic with both the size of the header but also its name and value. So again, the WAF's policies are protecting this. If we go into the details of these attacks, then we can see here a little bit more detail about what it's been denied and what it's been denied by, and further what category of attack it falls into. Now if that was something that we desired to be allowed through the WAF, we have this fix button here. And the WAF will recommend then what we should change and which security policy to enable this kind of traffic to go through. Now, not a good idea for the attack of this type, but if we were tuning the WAF to suit your application, then we might be enabling some of these features, as they might be outside of our default security policies. Now, the last log I'll bring your attention to is the audit log. As you would expect, this is an audit of the administrative changes that are going on in the WAF. So you can always see who's been doing what and what changes have been made. So the key thing with the WAF in Azure is that we would run web services. And underneath those web services, we then define our web servers. So what we can already see on this page is that we're running a service here on port 80. Okay, we can see we also have a secure service running on port 443, and behind that service we're running our backend service on port 80. So we're doing SSL offload with the WAF. The key thing to note here is that our security policy for this service is active. So we are preventing the attacks on the WAF and it is actively blocking the traffic. Now the additional service we have here, we have another HTTPS service, and you'll notice that this is running a different security policy, as are the services immediately below it. So we already provide a default security policy, but alongside that we provide additional template security policies such as SharePoint, which already contain the modifications needed to get that application up and running quicker. We also handle multiple domains. So in here we've created what we would call a rule group, and the rule group will allow you to specify different backend servers for different host names or different paths of your website. So those reports or the admin pages can go to a different site with different security policies. In addition to SSL offload, we can also control the certificates. So we can set this up for you so that you control your SSL ciphers. You can disable unsecure SSL ciphers. If we just look a little bit here, you can also handle multiple certificates, and we're aware of the host headers involved. So you can see here we've started to disable SSL version 3. In this case we're using our default ciphers, but we can select and pick from these and develop a stronger security policy as needed. Also, if you're scanning your site with a vulnerability scanner, then we can take in those reports. The WAF is able to support a number of common security scanners and can then, based on those reports, make recommendations to its security policies. Now these policies you see here, in the policy column, you have complete control over. So you'll see them here under the security policies in the policy manager. And if we just go into one of these policies for the moment, you'll see that you can create your own policies, adapt them and copy them off baselines. Once you've got your policy running, this is where we start to customize them. So the security policies are the general level of WAF security. A security policy is not necessarily a tight fit for your website, but is a general policy on what you will and will not allow into the site. So in this default security policy, we're controlling things like the number of cookies that can be in a request and the length of data that can be in the headers. So as we were looking at that block role before, we might want to increase this policy, and then all sites running this policy will be allowing that size header. Now that's great, and that makes it quite easy to maintain and manage. However, you might have some sites that need a little bit more security, or some cases for some legacy sites, perhaps some exceptions to how they handle these security. So if we leave our max name length header as it was back on 32, then that's fine. But what if your site needs more? Or what if just a page of your site needs more? And this is where the WAF can use its advanced features to really tighten the security of your website. So I'm going to nip in here under the Websites tab. Is I'm going to go into the more advanced tuning feature. So under Website Profiles, you'll see here now I have the ability to start learning. Now what the WAF can do is it can learn from the traffic coming into your site. So if I've developed my new website, I've put my WAF in front of it and I've run a couple of tests and I'm happy that the site is operational. But I don't really know what I'm doing with regards to my security policy, and I did make a mistake coding that page, so I need to temporarily allow a feature through. What I can do with my WAF then is pick my new site, enable the Start Learning button, and the WAF is now going to monitor every single browsing request I make to that site through the WAF. And it's going to monitor everything about it. So it's going to know that I went to the Contact Us page, it's going to know that the Contact Us page had 3 fields for me to fill in, one with an email address, one with my name, and one with some comments to be contacted about. Now I can then really tighten the security up by going in and looking at the values of those fields. So on this example, we have an action and a search query. And I can go into here, and if I wanted an exception to my default security policies, if I wanted them to be slightly tighter for this page, because this page in particular is handling a transaction or is allowing a free-form input, then I can start to customize it just for that URL, and in this case just for that parameter in that page. So with this type of security enabled and configured for each of your sites, you have got there the strongest and tightest fit of security for your applications, because the WAF knows exactly what should come into your website that is good traffic, and if it doesn't match those profiles, then it's going to be bad traffic. And with that in place, the WAF is now skin-tight protection for your site. I won't go into too many more of these features, but some highlights of what the WAF has here for you is we've got JSON security. So you can put it ahead of an API, either JSON or XML, and you can apply those same security rules and same inspection criteria to that data. So we can look in the API transactions for things like SQL injection attacks, for buffer overflows. We have a feature here called Trusted Hosts. Trusted Hosts allow you to define trusted groups of IP addresses where the browsing is not going to be attacks. And you can then make exemptions for these hosts to allow development activities to continue. Or you can tie this feature up, Trusted Hosts, with our other profiling method. So if the advanced learning mode is a bit too tight for your site, but you want the security policies to adapt a little bit better to changes to your application, then you can start looking at exception profiling and exception heuristics. Now the way this works is the exception profiling feature runs off of your trusted hosts, and it works on the presumption that all traffic from your trusted host group is not an attack on the site. Then, depending on how we control these definitions here that you can now see coming up on screen, we can make the decision that if a trusted host starts to, let's use this one as an example, upload some files that at the moment is in violation of our security policies threshold, once the trusted host has made that attempt 3 times, we should now start to consider that this is an acceptable new setting for the website. So 3 attempts to upload 5 files. Now I've received it from my trusted hosts. I am going to update the WAF security policies automatically to say, you know what, you're allowed 100%, 200% more of the current value. And so this can quite easily tune your sites to development changes without you having to go through and have a look at the web firewall log or to re-enable the adaptive profiling. So depending on the security profiles your sites need, you can run a combination of these features to adjust it. Now you may also notice here we've got a couple of other features. We've got web scraping. So this is a new feature in the WAF that allows us to detect other user agents and to block or whitelist those bots to allow them to catalog your site. We also have allow deny lists. So allow deny lists provide access control rules, and they can be based on the client IP. They can be specific down to a host header or a portion of your website. So again, if you're running some kind of CMS system where you have an administrative URL, you can start to use these access control lists to block access to the management paths but allow public access to the main site. Last but not least, on this page you've got the DDoS prevention, which allows you to control the number of connections coming into your backend servers. and it allows the WAF to prevent something that we call a slow attack, which is where the third party deliberately responds as if they're down a very, very slow internet link. And the idea there is to just tie up your server responding to their connections and not giving it space to deal with the legitimate connections on faster broadband. So under access control here, this is where you get your control over your authentication services. So what you'll see here is that we have a good range now of the WAF of authentication services that we can configure ourselves against, including multi-factor solutions such as RSA. You see here we can set it up with Azure Active Directory, with Kerberos, and with your internal LDAPs. With that done then, we start to work on the authentication policies, and these determine what server, site, and what part of the site are going to have the authentication applied. So in this example, we can see we actually have lockdown authentication for the admin site section, content management section of the bad store site. So then you can't get into those pages unless you've authenticated with an existing service. You can see here we've tied up a training site with Azure Active Directory, and again we've tweaked those security policies to say what can authenticate. Last but not least, if you want even tighter security, we can start tying client-based certificates, and the WAF can use those to authenticate the requests without having to put all of that into your server's logics at the back end. Now, a couple of last things about the WAF before we go into questions. Obviously, as you subscribe to the WAF, you're going to receive updates as we adapt to the changing environment in Azure. So you'll see here you've got Energizer updates, which are pattern updates, antivirus scanning updates, and they will all come through on a frequent basis. And then you will have the slightly slower firmware updates where we introduce major new features such as web scraping and updates to the security policies. You can also in here import your vulnerability reports. Obviously you can back up your devices, and as you manage multiple devices you're going to also manage your templates, your high availability and your cloud control from this screen. So that is an overview for you of the Web Application Firewall, what it can do for you in Azure, some of its features, and how you can utilize it. I think the best thing to do now is probably see if any of our audience have any questions.
Okay, thank you, Gemma.
Thank you.
Okay, so if you do have any questions, you can just pop those in the questions box at the right hand side of your screen. We'll just wait a minute, see if there are any. If you would like to submit any questions, so outside of the webinar, you can email the email address that's on your screen just there. Okay, so it doesn't look like we have got any questions today. So thank you everyone for joining the webinar today, and also thank you Gemma for presenting. And as mentioned previously, I'll send you all a link through to the recording this afternoon. So thanks again everyone, and enjoy the rest of your day.
Thank you very much for your time, people.